Okay, hey everybody. Thanks for inviting me. There's lots of good conversations so far. So yeah, my name is Briz. I'm a new media artist slash educator slash organizer from Chicago. I organize a lot of digital art events there. I also teach at the School of the Art Institute of Chicago. And I'm a creative director at a digital agency called Briz, and it's some of the work I'm doing there that I want to talk about today. So at Briz, we do a lot of different sorts of digital projects for a lot of different sorts of clients. And lately, we've been getting really interested in machine learning. So this is just a couple examples. We created this, this AI pipeline for the British band Muse, which some of you may know, which essentially creates so yeah, it creates sort of, it's a pipeline to create these algorithmic supercuts using AI. So they were uploaded to the band's YouTube channel on a daily basis and also their website. We're also working on a few installations for a children's museum in Miami, Florida, using real-time style transfer, which is also a popular area in AI research right now. But I want to talk about sampling and some of the work we've been doing in sampling in particular with machine learning. So this kind of sampling, I'm sure, especially at a conference like this, we're all very familiar with. Sort of the idea of taking pieces of music and recombining them to make new pieces of music. This has been around despite its tumultuous legal status. It's been around for over 70 years. It's spanned many different countries, many different genres. I'm also a musician, and the sampler is absolutely one of my favorite instruments of all the instruments that I use. But I'm also really interested in computer music and what's possible in that space. David Cope is a researcher from composer, programmer, who's sort of an early pioneer in this space. This is a project of his called Emmy Experiments in Musical Intelligence. We produced software that could create new works in the style of classical composers. I don't know if this is familiar to any folks or not. This is sort of AI. It's not machine learning. These are sort of more traditional handwritten algorithmic approaches, but it's sort of some of the predecessors to the work I want to talk about. So this inspired a piece that I did. This was sort of a weekend project that I wrote with a programming language called Pure Data. I got into an argument with my younger brother. He's a big Coldplay fan. I'm not as much a Coldplay fan. I was arguing that their work is really formulaic, so to try to prove my point, I sort of deduced what I assumed their formula was in this program that would then generate infinite sort of new, not yet written Coldplay tracks. And this is sort of what that sounds like. That could be a Coldplay track. Maybe also. So anyways, and those are MIDI files, right? So it's not like a full band, but I'm going to talk about MIDI and why that particular format's really useful in this area. So this is another program along the same line. So I started getting really interested in the idea of sampling not just not just the data, the audio recordings, but the metadata. So what does it mean to sample the style from a song? Or what does it mean to sample some other sort of pattern or signature in a song? So beats play a special role in the history of sampling. Sort of the appropriation of isolated drum patterns, or breaks as they're called, spawned entire genres of music. So I thought, how could I rip the metadata of a beat? And so what this program, this was written in JavaScript, and what this program does essentially is sort of find all the instances of kicks and snares and hi-hats and extracts not the data, not the sounds of the beats, but the sort of the pattern of the beat when these different instruments are played, so that I could then later reproduce the same beat but with different sounds, or combine the signatures of different songs and then reproduce them with different sounds. So this brings me to the work that we're doing at the studio, at the digital agency that I work at, Briz, with neural nets. So some of you maybe have heard this term. Neural networks is sort of one of the more popular areas in AI and machine learning these days. To explain a little bit for how that works, because the work we're working on, I think, raises a lot of new sort of intellectual property questions, but to really appreciate these questions, you need a little bit of an understanding for how the technology works, especially since this is so often anthropomorphized, and AI is often seen as like a living thing, but it's very far from that. So this is one of the most common applications, convolutional neural networks. This is often used to sort of classify images, and it kind of works like this. Somebody designs so a convolutional neural network is essentially a function that takes some input and then outputs some output. And they can be designed in different ways to take certain kinds of input and give you certain kinds of output. CNNs are usually expect images as input and give you a label or a class, a category as an output. But at first, they can't do that, because inside of this function, you have like these layers and layers, deep layers sometimes, of these randomized parameters. And in order to get those things to do something you want them to do, you have to train it, or what's referred to as train this neural network. And the way you do that is you collect lots of data, in this case thousands and thousands of images, and you need to label or pre-classify that training data, these thousands and thousands of images. That can be very expensive, or companies oftentimes trick all of you into doing that for them. For example, every time you filled out a CAPTCHA and you say, this is a car, this is a house, you're doing that labeling for Google. Or every time you tag a friend on Facebook, you're doing that labeling for Facebook. So they trick all of us into doing a lot of work for them. And then they take those labeled images and they run them forward and backwards through this neural network, which then adjusts all those little parameters, what are referred to as weights. And then this could start to perform incredibly. So it learns to generalize beyond the images that it has seen. So you can give it any image that it hasn't seen before, and it will properly label it. And this works tremendously better than the handwritten techniques. So the techniques that I use to write that Coldplay software or that David Cope used, these are handwritten rule sets. This is sort of the old way that we used to program, and this is a whole new approach for creating software, again referred to as machine learning. So you can use these neural networks to do generative processes, not just classifying and analyzing data. And the way you do that would be something like this. So let's say you wanted to create a neural network, and these are referred to as recurrent neural networks. This is another design. So say you wanted to create a neural network that can create new texts in the style of a writer, of a particular writer. So what you would do is you sort of take as much of that author's text as possible, and you chop up all the words into these little windows, that are referred to as n-grams of text. So in this case, maybe 10 letters per input. And the label in this case, the class, is the letter that follows that string. And then you go sort of like line by chunk, going through and training the neural net this way. And then you can get it to generate text by creating a sort of feedback loop. So you kind of start with some sort of seed, some input of text that you pass into this neural network. It then outputs a label, in this case Y. And then you take the label and you add it to the input text and then run it back through the neural network, which then generates a new label, O. And then you add that to the end of the text and you kind of keep going. And essentially, once you've trained this neural network, and when you train a neural network, that's referred to as a model. So you have this randomized algorithm set of parameters, you train it, and now you have a model that does something. And using a model this way, you can essentially create new texts of arbitrary lengths, in theory, in the style of the writer that you trained it on. And this approach to using RNNs comes from a paper by Andrzej Karpathy. This is 2 years old. He didn't invent RNNs. They've been around for a little longer than that, but they really started to catch on a couple of years ago when we started to see how effective they can perform. So this is some output from his particular design called char-NN, or character RNN, character as in texts. And you notice that at first, it's just kind of outputs sort of gibberish, garbage, but after multiple iterations of training, eventually the neural net sort of starts to learn sentence structure and syntax. Notice the capitalization at the end of the sentences. And then eventually it starts to learn simple, smaller English words and some larger English-like words. And then again, after further iteration, it slowly starts to catch on to all the patterns, in this case in Tolstoy's writing. And by the end, you have something that you could have been fooled into thinking Tolstoy wrote. That's sort of the last example there. So one of my collaborators at the studio, Brandon Dorsey, sort of took that same idea and applied it to music, to MIDI files. So the interesting thing about MIDI files, though they have that kind of low-tech computery aesthetic, is that the way that they organize the information is sort of sequential and distinct sort of notes. So it lends itself, that sort of file format lends itself really well to this sort of training. That's a link to a blog post if folks want to know a little bit more about specifically how this works. Also, some of our references are in there. I should mention that we're not the first musician programmers to sort of apply neural nets to music. This is something that a handful of other people are doing right now, but still very much in an experimental phase. Oh, so this is what the output from this model sort of sounds like. Now, to appreciate how poorly or how effective that's working, you kind of need to know how what it was trained on. How similar is that to the source material, of course? But the way we're imagining this to work, our sort of this AI sampler that we're working on right now, the sort of workflow kind of looks like this. So these are screenshots from the software, which again is still very much in development. So the first step is you need data, right? You need data to train this neural network. So you load up your music library into the program. So in our case, we're using over 100,000 pop songs that we have as MIDI formats, and we open up these 100,000 pop songs in this library. And then using a few other machine learning techniques, we sort of arrange them in 2D space based on sort of structural and stylistic similarities. So it's sort of zooming out there. And then you could explore this 2D space, and you could click on the dots and listen to the music. And then the idea as a musician would sort of explore and try to find melodies that kind of suit their aesthetic sensibility. And then you kind of select a chunk of pop songs, and then you use that to train your own model using this MIDI RNN neural network. And then, once you have a trained model, you can output, brand new melodies infinitely. And this is sort of a classic kind of piano roll interface, which a lot of musicians are sort of familiar with if you make digital music. You could kind of keep generating new models. When you find something interesting, then you do what you want with that. You might take this and import it into some other music tool, or you might use it almost like the way you use sheet music and just kind of re-record yourself the MIDI track. So that's what I did as a quick example. So I'll play you one of the outputs from the RNN, and then I'll play you a recording I did with more traditional instruments, a guitar and a synthesizer. So that's the output from the RNN, and then this is just a regular recording. Time's up, so I won't play that whole song. I'll just wrap up and say, had you just heard that recording on its own, again, that recording never existed before I recorded it. It would be easy to convince you it was original music that I wrote and recorded myself. But there's a lot of players here and a lot of interesting IP questions, right? Because there's the model that was trained, which I might myself not have trained using an algorithm that my collaborator Brandon Dorsey wrote for that neural network, and then using a whole bunch of copyrighted music as the data to train that neural network. So there's a lot of different potential IP players here, and depending on how we answer the copyright question, I think will determine whether we see another 70 plus years of really interesting innovation in music or not. So thanks.